Okay, so the 2024 Stack Overflow Developer Survey is out. It's always a really interesting read. We're going to go through it together. I've been a developer for the past 10 years professionally and been leading software teams for the last 5 years. So I'll try and inject some of my working knowledge as we go through it and a bit of my experience. I think some of the sections in the survey are a bit misleading and some of the categories are not placed in the right area, so I'll highlight them as we go through, but mostly it's a really useful survey and it's really worth a read. So we'll go through it together now and take out the best parts of it and of course look at the salary chart as we get towards the end of the session. So apparently they built this whole microsite in Svelte. We'll get to Svelte a bit later, but there's quite a nice homepage here that gives you an overview and some cards with various figures on it. So let's start out by looking at the methodology, just to check we understand what we're actually looking at before we get into the details of the programming languages. So they had around 65,000 responses from 185 countries. What I found interesting about this here is they actually didn't use 20,000 of the responses. So they say they had an attention check question, a consent question, and a question asking which of the following options best describes you today. I'm not sure what the potential answers were for that, but either way that filtered out around 20,000 of the responses. So it does seem like they've curated this data in quite a nice way, and we've still got quite a large data set to work from here. 48,000 of the responses were used to provide aggregated salary information, so we'll get onto the salary information a bit later, and it took people around 21 minutes to complete this survey. The salary information we'll see will all be in US dollars, but of course that's just been converted based on the exchange rate on June the 11th, 2024. I'm going to skip over this feedback section here because you're probably not too interested in that, but this section is quite interesting. Around 76.7% of the respondents were professional developers. So some of the other respondents are either learning to code or coding as a hobby or ex-professional developers. So as we go through the technology section, I'm probably going to filter most of them by the professional developers because that's what we're mostly interested in here, what are professionals doing in the market. Obviously, people that are learning to code will be using very different technology in some cases to people that are being paid to do so. So let's start off by looking at the developer profile. So again, I'm going to filter this by professional developers, and we'll see that 45%, just over 45%, have a bachelor's degree, and just under 30% have a master's degree. Interestingly, 0.6% apparently didn't make high school, which is quite interesting there. And software development is one of those fields where you can certainly enter it and do very well without having a bachelor's degree or higher. Okay, learning to code. So other online resources takes up the vast majority of ways people learn to code. And of course, in the younger generation, 18 to 24-year-olds, they might be learning at traditional schools such as a college. So if we scroll down and look at these online resources, we can see that almost 84% of them are technical documentation and 80% are Stack Overflow questions. Now, technical documentation is a great way to learn either a new language or an existing one. So for example, if we type in here C# Microsoft Docs, and we click on the first link here, we go to learn.microsoft.com, and the documentation on here is really fantastic. They've got a getting started area, they have some training videos, and if we start off with the fundamentals here, we can see this sidebar really does elaborate in as much detail as you want, starting off in the very basics, then getting into some advanced concepts here like asynchronous programming. Same thing for JavaScript. If we just do a search for JavaScript, I'm imagining the top result. Near the top result will be the Mozilla page, developer.mozilla.org, and this has extensive documentation, again, very clean, very easy to read, and very easy to learn from. So if you're ever picking up a new language, check that the documentation is good. These are kind of two gold standards for it, in my opinion. And we can also see that written tutorials, blogs, how-to videos, and other e-course based videos are popular methods of learning. So if we dig into this technical documentation a bit more, we can see that the API document or the SDK documents are the most popular form of learning. But user guides or README files found in the source repositories are a close second. So if you want an example of that, if we type in Umbraco GitHub into a search engine, and Umbraco is an open source .NET CMS, but really any project should have a high quality README file. So we can see this has got 4,500 stars. And if you just scroll down on the homepage of the project on GitHub, you'll be able to see the README file there. And ideally, it will always start off with an introduction to what the product is, give you some installation instructions, and then point you in the right direction for some more comprehensive documentation. So this is kind of a good example of what to expect there. And if you're building your own open source project, this is certainly a nice way to present it, and it will help other people find and learn how to use your project as well. So moving on to experience, we can see that the majority of people have between 5 and 15 years of experience, which is obviously quite a large time span. We can see here more than 1 in 3 developers that took the survey this year have been coding as long or longer than Stack Overflow existed. Stack Overflow started in 2008. So obviously around 16 years there. Apparently there's some people that have more than 50 years experience coding. Now this isn't professional, this does include education and hobbyist coding. So if we scroll down a bit to years coding professionally, that's even less at 0.1%. So if you'd started your professional career 50 years ago, in 1974, you could be working with C, which was released in 1972, Lisp, COBOL, Pascal Basic. There's a few options there, and some of those are obviously still around. But it is amazing to me that there's people that have been doing it that long. The majority, of course, much less time, but still quite experienced there. And the 1 to 4 year mark is still very high on this list, and that's going to be the junior developers. So moving on to the years of professional experience coding by developer type. Now, this is one of the sections that confused me a bit because a lot of these roles are listed here are not developers. So it says here by developer type, but for example, in the list, we have product manager, we have project manager, we have a designer, we have a marketing or sales professional. And these are obviously not roles that you would expect to involve any sort of coding or software development. They are people who help refine the product that's required from the business point of view. So I work with product managers, business analysts, and they will define the scope of the requirements and tell us what it is they want us to make, what business problem are we trying to solve by writing code and developing applications. But of course they don't write code themselves. Anyway, regardless, skipping over those roles, we can see if you're expecting to be a senior executive, so a C-suite kind of person like a vice president, you're probably going to need around 17 or more years of experience. It does say manager here, engineering manager, it's obviously quite a broad section there. But the managers either way had around 16 years of experience. Hopefully that's not too disheartening to anyone that's hoping to become a manager in the future, because I got my first management role after only 5 years as a developer, and only one of those years had been as a senior developer. So third here, you're going to need around 15 years or more experience to be a developer advocate. Now, a developer advocate apparently is someone whose job it is to help developers be successful with a platform or technology. So it's insisted that that isn't a sales job, but essentially their role is to promote the use of their technology amongst developers, to kind of help with that marketing drive and tell you why, as a developer, it would be good to use their tool or programming language or service or whatever it is. So I can see why you'd need a lot of experience to do that, mainly because you're going to have a good network of developers and organizations to actually promote your product within. So we can see moving down the list that some of the other roles here, such as research and development roles, embedded applications, developer experience, cloud infrastructure engineers, these have over a decade of experience on average. But as we move down towards the more practical, the more day-to-day kind of people that are going to be writing the code, we can see that the average experience level drops slightly. So a back-end developer apparently has an average of 10.7 years experience, full stack around 10.5 years. And then as we get down to some of the more specialized roles, such as games developers, AI developers, or front-end developers, the experience required is a bit less. Front end is, well, pretty much at the bottom of the list here if we don't include students, and that's probably because it's the most common entry point from what I've seen for junior roles. So usually when someone comes straight out of college or university and they're applying for junior developer roles, it will usually be as a front-end developer because those are the most popular kind of frameworks that are picked up by people leaving university now. So they will have picked up something like React or TypeScript or just plain old vanilla JS, and they'll be wanting to work on the front end of an application, and it's certainly a good entry point and a good way to move into other areas or become a full stack developer. Now, for those of you that don't know, that watching a full stack developer would encompass at least 5 different things. So you would at least be competent as a front end developer, as a back end developer, with some sort of cloud service, so AWS, Amazon Web Services, or Microsoft Azure, something like that, which we'll get onto later. Some sort of database technology, so Microsoft SQL, for example, SQL Server. And you should also have a good working knowledge of DevOps. So how do you actually build and deploy infrastructure that will host and run your applications? So obviously, if you're using something like Azure, it will take care of some of that for you, but you're still going to have a repository system somewhere that you'll need to use to actually build and run tests and deploy your projects to. So that's probably the reason full stack developers have an average of 10 years or more experience, because it takes a long time to build up knowledge in each of those domains. So if we move on to developer types, we can see that full stack backend and front end developers are the top 3 roles for the last 3 years. However, front end developers have decreased from 6.6 to 5.6% since last year, and that's probably to do with some of the layoffs by some of the big tech companies. This year, more developers identify as students than as front-end employees, and they saw a slight increase in developers who have an embedded applications role or are academic researchers. So we can see going down this list, if we get past the top 3, which are our full stack backend and front end, excluding students there, we can see that really the rest of them are very niche. So we can get into data engineers, DevOps specialists, games developers, system administrators, etc. Now, you'll see QA in quite a lot of these lists. QA is a quality assurance specialist. In my experience, these aren't usually developers, and I, again, wouldn't include these in a developer type list because unless they're like an automation engineer and they're writing automated UI tests, which often the developers will do anyway, usually QAs are doing a lot of manual testing or running tests that developers have already written. So although QAs sometimes do get involved with writing code, they usually don't in my experience. So I probably wouldn't have them on this list. Same thing for a product manager there. And certainly for marketing or sales professional, which is why you probably see 0.2% on the developer type list. So the geography we already covered, but we can see that a lot of the respondents are coming either from the United States or from various European countries. And when it comes to age, as expected, developers tend to be on the younger side, although interestingly, the largest pool was 25 to 34-year-olds, and obviously it tapers off after that. All right, so let's get into the technology. This is probably going to be the most interesting and the biggest part of this survey, so let's have a look at what people have said. Okay, so I'm going to filter again by professional developers, and we'll see that JavaScript is overwhelmingly at the top there. Now that's probably because that's going to encapsulate all of the front-end frameworks that use JavaScript. So Vue.js, React, Next.js, Svelte, they're all going to be captured in this. So that's probably the reason JavaScript's so high on this list. Next we have SQL. HTML, CSS, well, I guess it's a markup language, but really if you're doing anything on the web, that's going to be in there. PY is Python, TS is TypeScript, Bash Shell, Java, C#, C++, PHP, and C. Go is a open source language which is developed by Google, so we can see that it's actually increased in popularity a fair bit. I think that was much further down the list in previous years. As we go down this list, we can see it becomes more obscure with NIM there at the bottom at 0.2%, and we'll talk about NIM a bit later on because there's an interesting correlation between this and the average salary for that programming language. Okay, moving on to databases. PostgreSQL is at the top there. We can see it debuted in the developer survey in 2018. 33% of developers said they were using it then. And now we're all the way up to 49% pretty much. So the top 4 in this list are basically all variations of SQL, and then we get into some other databases like MongoDB, Redis, MariaDB, Oracle, and some much more obscure ones. Many of these I've not heard of at all. So in terms of cloud platforms, Amazon Web Services seems to be at the top here, Microsoft Azure and Google Cloud. So these top 3 are no surprise at all, really, although the discrepancy between them is, to me. I do work in the Microsoft space, but with my experience being a .NET developer, almost everyone that I know is using Microsoft Azure. So I guess there's slight availability bias there. But either way, Google Cloud and Cloudflare and Firebase are after that. And then it really drops off after that. Okay, web frameworks and technologies. So I'm going to filter this again by professional developers, and we can see that the very top one is React, as it has been for the past couple of years. Node.js apparently peaked in 2020, where it had 51%, but it's still up there anyway. jQuery, interestingly, is number 3 on here. Now, jQuery version 3.7 was released in May 2023, but there was a beta of version 4 released in February 2024, and that's still in beta. So it's still under development, but certainly less popular than something like React. And a lot of people associate JavaScript with jQuery. You know, that is their interface into JavaScript. They'll just use jQuery functions rather than vanilla JS ones because it is a lot cleaner and easier to use, and also has a very small bundle size. So after that, we can see Angular, ASP.NET Core, Next.js, Express, and then moving along, we can see Vue.js, ASP.NET. We can see WordPress in here as well, and Svelte, as we mentioned earlier. So that's kind of another component-based framework, the same way that Vue.js and React is, but again, it has a much smaller bundle size. So the difference really is in the size of the project. So Svelte's really good for small projects, small to medium-sized projects really, where you've got simpler components, whereas React is something that you might use for a bigger, more enterprise project. So that's probably why you're seeing it quite low down on this list. The adoption rate is still low. But the people that do use it have very good things to say about it, and we'll get into that section a bit later. And we can see under Svelte we have Blazor, which is a component-based framework, is a .NET framework that allows you to create components in C# and HTML. The adoption rate is fairly low for that, and from my experience, the few people that I've heard that have used it in the .NET world said they've had quite significant issues with performance, and that seems to be quite universal when I've done further research into it. So I think that's holding it back at the moment, and it's probably not going to be adopted until that's kind of resolved, if it can be. Okay, so moving on to embedded technologies. Again, 39.1% of professional developers say they use Raspberry Pi. Then we have CMake. Lots of things in this category, but my guess here is that this is mostly for personal use. I don't think it's very common that you would use these kind of embedded technologies in your day-to-day role as a software developer, but software developers are the type of people that would buy a Raspberry Pi and install it to create some sort of home network or tinker with other things at home. So I'm guessing that's why that's so high up on the list there, but it doesn't actually say whether the usage was in a professional context or not. So they may be professional developers, but just using these technologies as a hobbyist in some cases. CMake is really useful for developing cross-platform projects. So basically you create a CMake lists.txt file, and then it creates things like Visual Studio solution files and that kind of thing. So if you're developing on different operating systems or in different environments, that kind of simplifies the process. Not something I've used, but again, it seems to be quite popular as an embedded technology. Arduino is similar to Raspberry Pi. They're boards that have microprocessors, controllers on them, etc. But these can be programmed in C or C++, I believe. Okay, so moving on to other frameworks and libraries. It says here .NET is the most used among other frameworks and libraries. Again, this year for all developers, as it was last year. Those learning to code are using NumPy and Pandas the most, as they were last year. And that's probably because people learning to code are overwhelmingly learning Python. So if we filter this by professional developers, we can see 27.1% are using the .NET framework or .NET, so .NET Core as well. So Pandas is the Python data analysis library, so it offers data structures, operations for manipulating numerical tables, that kind of thing. NumPy, again, another Python library. So this one's used for working with arrays. So it adds support for multi-dimensional arrays, matrices, and other mathematical functions to do things with those arrays. RabbitMQ here, something I've had a bit of experience with. It's a message queuing software. So some people call these message brokers or queue managers, but if you have any software that's sending messages, RabbitMQ is a good solution for managing those and being able to see them all in one place. And then scrolling down this list, we can see at the very bottom here we have JAX. That's probably because it had only been out a month when this survey was released. So JAX was released in May, I believe, this year. But again, it's a machine learning framework and it's to be used with Python. So it transforms numerical functions. It's described as bringing together a modified version of autograd, which is the automatic obtaining of the gradient function through differentiation of a function. I don't know what that means. So moving on to other tools. So Docker here is at number 1. So Docker is used to deliver software. So you create packages, which are called containers, and then you can use that to simplify the deployment process. So this was actually written in Go, which we talked about earlier, the Google language. And NPM is a close second. That's Node Package Manager. And then we have pip at number 3. So the difference between these two is NPM is mostly used for managing JavaScript packages, whereas pip is used for managing packages in Python. And then as we go down this list, we can see various build tools and bundling tools such as Vite, Yarn, Webpack, which is quite old now, and you can see it's been overtaken by Vite, which claims to be a lot faster. Visual Studio Solution, MS Build, which comes bundled with Visual Studio. Chocolatey, that's a really useful one if you have, for example, a new machine and you have a whole list of software that you want to install off the bat. That's really useful and really simple to run as well. Unity 3D, again, for the game developers there. Unreal Engine, again, for the game developers. And we have Chef here at the bottom. So when it comes to IDEs, the integrated development environment, this is where you're writing your code. This is where you're managing your code files and basically doing 90% of your role as a programmer. So Visual Studio Code is number 1 on here, and I'd imagine that's because Visual Studio Code is the number 1 IDE to use for front-end projects. So if you're working in React, or any of the other modern kind of component-driven frameworks, so Vue.js, Svelte, etc. Visual Studio Code makes it really easy to do that, and there's also some really nice packages that you can install that magnify that experience even more. And then Visual Studio is second. Obviously, there's a big discrepancy there because Visual Studio Code will be used mostly by front-end developers, and Visual Studio would be used by either full stack or a back-end developer who's actually running the entire application, or running your C# code, etc. IntelliJ IDEA, I'm not sure how to pronounce that, but it's a JetBrains IDE, and it's for Java, Kotlin, Groovy, basically any JVM-based, which is a Java virtual machine-based language. We also have Notepad++ on here. That's certainly not an IDE, so again, it's questionable that it's in this list. I'd imagine that people are using Notepad++ to edit single files, so I've used it before to do things like edit web config files and that kind of thing. I've kind of changed my approach now and just use Visual Studio Code for those kind of things, but I do know of people that will just use a text editor like Notepad++. But again, it's not an IDE. You can't actually run anything or do anything from Notepad++, it's just a text editor. Speaking of things that are just text editors, Vim as well is on here. Vim's not an IDE either, it's a text editor. You can kind of make it IDE-like, but it takes a lot of effort to set up and get into that state. The selling point of Vim is it has optimized key bindings, but you can set that up in any IDE. Android Studio is for mobile development. Moving down, we can also see NeoVim on here, but that's just Vim again. It just has an improved plugin architecture. The thing about these kind of tools like Vim is you often see junior developers come in and they're kind of excited by it and they want to use it. But when you're working on a software development team, maintainability and portability is really important. So if the rest of your team aren't using it, it's kind of a no-go really. Obviously you could suggest it to the rest of your team and see if you could maybe trial it, or if a couple of you could look at working on it together. But if your entire team is using Visual Studio Code and Visual Studio, and you decide to use Vim, it's quickly going to create problems for you. So I definitely wouldn't recommend doing that unless the rest of your team are. And as I said, it's also not an IDE, so I don't even think it really belongs in this list. And then moving down, we can see some other more obscure IDEs like Rider, which is a JetBrains product. Again, I've heard that's really good, and its performance apparently is excellent, but the adoption rate is fairly low, although it's more cross-compatible with using with Visual Studio projects, so solution files. So there's lots of things on here that you can try. Moving on to asynchronous tools. So what is an asynchronous tool? It basically means how are you managing your project. So you can do this by managing tickets, cards, user stories, features, epics, all of the other nice things that you have in agile software development, or really any other methodology. So the number one tool on here is Jira, Confluence. So these are Atlassian products. Markdown file. Not really sure. I mean, obviously lots of products integrate Markdown, and this people might have selected this just because they include README files in their projects. Either way, Trello, Notion, Azure DevOps. That's probably my favorite one because it integrates really well with Microsoft Azure. So if you have a repository and you want to have build processes that will then automatically deploy so that you can have a CI/CD set up into something like Microsoft Azure, it integrates really well there into that ecosystem. So that's kind of my preference, but Jira is also really good and has the same kind of functionality. So a lot of these are much the same really. ClickUp's also a good one, but it does everything on the front end, so it can be quite slow, especially if you've got a lot of information in there, but it does have a nice UI. Okay, moving on to our synchronous tools. So this is basically our communications tools. So Microsoft Teams, Slack, Zoom, Discord, Google Meet. Probably none of this is really a surprise, and I also don't think it really has a massive effect on the development experience. So we won't spend too much time looking at this one. We can see in terms of operating systems that most people are using Windows, Mac or Ubuntu. Obviously, the large majority are using Windows, both professionally and personally. We do have some mobile operating systems down here, but I assume these are either virtualized instances or it's for testing purposes. So if you're developing a mobile application, that you might do some of that on the original, on the OS that you expect your users to be using. So I very much doubt there's any full-time software developers, for example, using iPad OS or Chrome OS. So it's hard to tell exactly what they mean by this. But yeah, I very much doubt there's people using those operating systems as their primaries. So moving on to AI search and developer tools. So ChatGPT is obviously at the top here by quite a long way, and then GitHub Copilot. I expect the discrepancy between these two is simply that ChatGPT is free, or at least has a free tier, whereas Copilot has a free trial, but then you have to pay for it. Obviously, the benefit of Copilot is it's integrated, so Copilot can be integrated into your IDE like Visual Studio, whereas ChatGPT is something that you would use in a browser. And I actually think that's another reason ChatGPT is more popular, because a lot of developers don't want the AI tool permanently prompting them in their IDE. They kind of just want to be able to poke it when they need to in their browser, which is exactly what I do. I think tools like ChatGPT are great for developing or analyzing small snippets of code, but when it comes to looking at projects as a whole, they're still a long way off from really being useful in that context. And we can see there's a whole ecosystem of these kind of AI tools developing here. Okay, so moving on to admired and desired. So the blue line on the left is how much it's desired by, and the red is how much it's admired by. So my interpretation of this, although they don't explicitly define it, is the red, the admired, is the percentage of people that would like to carry on using it after using it. So we have Python at the top here, so we can probably assume that 67.6% of people that used Python liked it and would like to continue using it, and 41.9% of developers not using Python would like to at least give Python a go. So we can see JavaScript. I would imagine that some of the people here, so 39.8% of people that desire JavaScript would just be people that aren't working in a front-end role. So it could be, for example, a back-end developer or a data scientist that just wants to do some front-end development. If you're in any kind of full stack or front-end role, this would be 0 because you can't really avoid it. We can see also here that people are quite satisfied when they're using Go, Bash, Shell, C#, C++. And the satisfaction of the language seems to be a bit lower for R here, which is a statistical data science kind of language. It's very low for Visual Basic, and I'm not surprised at all there. The same thing for VBA. This was kind of pretty much discontinued back in 2007-ish, as when Microsoft stopped issuing licenses for VBA. So the likelihood here is that it's people maintaining old systems that don't really want to be. So 75% of them would like to move on to something else, it seems. And moving on to the admired and desired list for databases, we can see that an overwhelming majority of people using PostgreSQL are very happy with it, and SQLite as well. And really for the rest of the databases, there's not much in it, although you can see Oracle scores quite a lot lower on the admired list there. Not many people seem to be enjoying using that. The same thing with Cassandra there. Microsoft Access has an extremely low rate, but again, similar to the VBA Visual Basic situation, it's long dead, and it's probably people reluctantly working on old systems that they don't really want to be. So cloud platforms is a similar story, around 50 to 60% for most of them in terms of the admired percentage. You know, how much do they want to continue using it? It says here that Hetzer is the most admired cloud platform for the second year in a row with a 75% score, rising from 70% last year. So they've obviously made some improvements there. And moving on to web frameworks and technologies. So apparently, 73% of developers that used it want to keep working with Svelte. As mentioned earlier, the Stack Overflow team used Svelte for the first time in building this developer results site. So they seem quite happy with it, and the people that are using it are quite happy with it. So it's surprising to me that the adoption rate is still so low. If we remember from earlier, yeah, so the adoption rate here for Svelte was 5.9%, whereas the satisfaction rate is actually very high for it. So hopefully we'll see that increase a bit more next year. And then speaking of technologies with a low adoption rate but a high satisfaction rate, HTMX is here as well. So HTMX allows you to call JavaScript functions without actually writing any JavaScript. So you can do it with elements instead. So inside your elements, you can add attributes, and you can add, for example, clicked attributes, and when it's clicked, it will do something, like make a post to an API endpoint. You can also use any HTTP verb, so you don't just have to use get and post requests. And there's reports of people reducing their code bases, their React code bases, by 60 to 70% by using HTMX. So again, very low adoption rate. I haven't personally heard of anyone using it professionally, but the people that do seem to be very pleased with it. So that's probably something worth experimenting with. The other big thing about HTMX is it actually allows you to update only the component that made the request if you want to. So with traditional JavaScript, you'd have to refresh and update the whole DOM, the whole window. But HTMX allows you to update components. So essentially, you're getting a lot of the benefits that you get from a component library like React, but in a much smaller bundle size and much simpler programming concepts. Essentially, it's just HTML with some attributes. So worth looking into, I would say. And then as we go down the list, we can see some other less adopted technologies on here, such as Strapi, which is an open source JavaScript CMS, Gatsby, Drupal, some other things. So going back to embedded technologies, new to the survey this year, Cargo comes in with a very weighty 83% admire score. Raspberry Pi, everyone seems to be happy when they're using that. The Arduino boards that we mentioned earlier are similarly popular, not much further down, but they seem to be a lot less satisfied with using them, around 60% there. And then moving on to the satisfaction scores for some of the other frameworks and libraries. .NET, again, very high here. NumPy, which is a Python library. Pandas, which is more Python, we talked about earlier. And then the .NET framework satisfaction seems to have gone down considerably, but again, I would imagine that's because it says here it's .NET Framework 1 to version 4.8. After that, obviously, it moved on to .NET Core, which is now just .NET. So I'd imagine the satisfaction rate's a bit lower because it's people working on older systems that would like to be working on newer versions of .NET, i.e. Core and later. Looking at other tools, people seem pretty happy with Docker, Kubernetes, pip that we talked about earlier, Vite as well, which is kind of a bundler and a build tool for front-end projects, and I've used it and have also been very happy with it, so I definitely would recommend that. I used it as a replacement to Webpack, sort of a more modern replacement, and it looks, if we look down here, we can actually see Webpack at 39%, so I do know of a few people that have done something similar. And if we look at the satisfaction for IDEs, we can see most people are very happy with Visual Studio Code, Visual Studio, Vim, NeoVim, and some of the other ones that we talked about earlier. So moving on in this section, there's a worked with versus want to work with chapter. I don't find this particularly helpful because the way that the data is represented here is just not really very easy to read. I mean, you can hover over a section and it'll tell you, for example, 14,000 people who worked with HTML, CSS want to work with TypeScript. And you can hover over each one and it'll tell you which developer in a certain field wants to experiment with a different technology. But obviously, just looking at this from a high-level perspective, it's hard to kind of abstract anything useful away from it, in my opinion. So I'm pretty much going to skip over this entire section here. Okay, so now we move on to the interesting part, looking at the top paying technologies. So who's being paid the most per programming language. It's worth noting this can be a bit misrepresentative of what's really happening. So we'll go through them, but then we'll talk in a bit more detail about why these figures might be in the order they're in. So Erlang here is number one. So Erlang's a programming language used to build massively scalable soft real-time systems with requirements on high availability. The short version of that is basically it's used in telecoms, banking, e-commerce, telephony, instant messaging, that kind of thing. So it's a functional language, and it's probably being paid quite well because it's being used by companies that have a very stringent requirement for 100% uptime, or as close to it as you can get. So that's what they mean when they say high availability. If you're a telecom service, you certainly don't want your services to be down. So they're paying people pretty well in exchange for that. Elixir, a dynamic functional language, but Elixir runs on the Erlang VM. So essentially it's just an extension there. So we could kind of bundle those two together, I guess. Closures on here, so that's another functional language. This is a dialect of Lisp. Lisp is a bit further down here. $15,000 discrepancy between those two though, so you're probably better off learning Clojure if you're interested in diving into the world of Lisp. Now interestingly, fourth in the list is Nim. So Nim compiles to C, C++, JavaScript. So Nim is statically typed, which basically means the variables are known at compile time. Unlike something like JavaScript, where you don't actually know what the type is. So even though this is fourth in the list, paying an average salary of $94,000 a year, if we actually go all the way back up to our technologies, programming, scripting, and markup languages, we can see Nim there was at the very bottom at 0.2%. So I think some of the reason that these languages are higher up is just because they're a lot rarer. And so even though this might be the fourth highest paying language on the list, there's probably very few positions available that are requiring specialists in that language. So just because it's high on this list essentially doesn't mean it's a good idea to go for it. In fact, I would say some of the languages much further down this list will probably be a much safer bet in terms of career options. So as we get down to the kind of middle of the list here, we've got Python, C#, TypeScript, SQL, C++. So these ones might be paying less, but there's considerably more market for these kind of positions. So these are a much safer bet and don't require the kind of intense specialism that some of those languages further at the top have. So moving on to the salary changes, so we can see, except for Nim, Erlang, and Apex, all developer salaries actually reported a decrease in median salary from 2023 to 2024. There's probably a variety of reasons for this. So there's obviously political events that happened in 2023. There's an increase in the number of developers. So some reports that I was looking into said there was a up to 15 to 20% increase in the number of developers since 2020 over the past 4 years. There's remote working, which has enabled outsourcing. There's layoffs from some of the larger companies from the back end of kind of a boom there. And it does seem that the junior and the less experienced developers are affected the most here. So it's still pertinent really to develop some kind of specialism. So if you want to be a cybersecurity specialist or a blockchain programmer, you're probably not going to experience the same decreases that some of these have had. We can also see that a lot of the heavy decreases are in front-end kind of languages. If we go down here to, HTML, CSS, JavaScript. And the reason, again, as we mentioned earlier, is a lot of those roles are junior developer roles. But even some of the back-end ones like C# and C++ have seen that decrease there. So we'll see what happens next year and see if these come back up again, which I expect they probably will. Okay, AI tools in the development process. So most people are using AI tools in some kind of way. And the majority of them are favorable or very favorable of them. And the reasons here are fairly obvious: increased productivity, speed up learning, greater efficiency, etc. But what's interesting about these results, if we filter it again by professional developers, is you can see that only 2.3% of professional developers highly trust the accuracy of AI tools. And I would certainly put myself um, in the category of highly distrust here, because I've got a fair amount of experience of passing code to various AI tools, including Copilot, ChatGPT, Claude, etc. And they can be useful, but they very, very often get things wrong, introduce bugs, and that kind of thing. So I would never rely on them to write any kind of production level code that wasn't heavily checked first, by which point you may as well write it yourself. So I can definitely see why this result kind of looks like that. And again, this is just kind of an elaboration on that. Only 3.3% or 2.9% of professional developers think that an AI tool does very well at handling complex tasks, which I totally agree with. Again, I would say very poor at handling complex tasks, and does very well at handling simple tasks, such as generating simple code snippets and that kind of thing, which again the IDEs are getting so much better at now. Anyway, it kind of limits their use case in a lot of cases. So looking at where they use AI in the development workflow, sadly 82% say writing code, but hopefully that's not production code, or at least it's not code that they're going to review very heavily first. For me, debugging, getting help, looking for answers, testing code not so much, but just giving it as another set of eyes, as you might do with a human, is kind of useful. I would say you would give it the same level of responsibility when it comes to looking at code that you might give to someone who has 6 months of experience, that kind of thing. And apparently in the next year, most developers agree that AI tools will be more integrated, mostly in the ways they're documenting, testing, and writing code. So there isn't really a doubt there that it's going to become more integrated, but hopefully, again, this isn't something people are going to rely on to do any of those things. Your code documentation should certainly, at this stage, be a manual process. One of the issues I've seen with AI is it introduces a lot of bloat, even when it does get something right. So, for example, if you pass AI some requirements and ask it to write you some user stories in kind of an agile format, it will do that for you, but it introduces a lot of bloat and makes it quite hard to read. So it can turn sometimes a 3-sentence acceptance criteria into a 3-paragraph one, which you don't always want, of course. And based on everything we've just covered, we can probably see why 70% of developers don't see AI as a threat to their jobs as it stands. And they've included some questions here around ethics for AI, which mostly seems to be a bit of a theme here, circling misinformation or disinformation. And I've definitely seen that happen myself. And again, not trusting the output or the answers that the AI has given you. So moving on to the work section, there's some employment status questions here, with most of the respondents, at least the professional developers, being employed full-time. And then there's some more geographical information on here. We can also see that 42% of developers are now hybrid, and 38% remote, but only 20% are in person. Presumably that means people that are in person in an office full time. So 80% are in the category of either hybrid or remote. And it also looks like most people are working in sort of small to medium-sized organizations, going up to around 500 employees, and then it really tails off after that. And apparently 2% of people don't know how many employees are in their organization, which I guess is a fair answer for some of the really big ones. So going back to some of the salary information, these are the salaries by developer types. So obviously the senior executive, a vice president of software engineering, for example, you would expect them to be commanding the highest salaries, which they are there. The developer advocate role that I talked about earlier, so again, those people that are kind of promoting technologies within the developer communities, I was surprised to see them second on this list. They're obviously being paid really well. And we can see that development engineering managers are third on the list here. So the summary does say the highest paid developers of all respondents are site reliability and cloud infrastructure engineers, as both roles are pivotal in keeping digital services up and running. So yeah, again, these are people that are keeping your infrastructure alive. So if you're working on something like a Azure DevOps or a Microsoft Azure environment, they'll be the people looking after the servers and the databases and the virtual networks and that sort of thing, making sure that your applications are actually online. So I agree with that sentiment. You can see why they're being paid a bit more there, such as your cloud infrastructure engineer here. So moving down the list, we can see kind of in the middle of the list here, we have some research kind of roles, academic roles, so research and development roles, scientist, data scientist, or machine learning specialist. And then moving further down the list again, we can see that we have back-end developers here. Again, I don't know why marketing or sales professionals in this list. We can see games developers are quite low on the list, which is probably not a great industry to be in, to be honest, because it's lower on the pay scale because it has a lot of people that want to work in it. There's a very high rate of kind of desirability there, but it's also combined with pretty heavy hours from what I understand. So we can see front-end developers at the bottom of this list, and that's probably because a high percentage of those roles are for junior kind of positions. So as we discussed before, unsurprisingly, the more experience you have, the more money you can expect to earn, with senior executives, dev associates and managers being the most experienced and the most highly paid on this list. And obviously the front-end developer being at the bottom end of both of those. And you have a whole bunch of stuff in the middle here. And then somewhere in the middle of that, you have your back-end and your full stack developers. So if we scroll down a bit here, we can see that they might have on average around a decade of experience, and then be in the middle of this kind of salary range. Again, I wouldn't let these numbers put you off if you're not quite in one of these roles yet, but you want to be. So if you're a front-end developer hoping to be a back-end or full stack developer, don't think that you have to wait until you have 10 years experience for those roles. I certainly didn't. I had my first full stack role after just a couple of years of experience. So as long as you learn quickly, you don't have to wait until you've got this level of experience to go for these kind of roles. And then this chart shows something similar. So salary and experience by language. So developers that are using Erlang and Clojure are the top earners in the past year. So they're averaging more than 95k US dollars annually with about 12 years experience. And apparently developers working with Dart and Prolog are earning the least, so less than 45,000 a year, but they also have a bit less experience there. But the important thing to note here is the average salary is 60 to 75,000 US dollars this year, which has seen a roughly a 10k drop since last year for the reasons we discussed previously. And we can see here that most respondents have some kind of influence over the technology purchases, so that's quite a nice thing to see, because at the end of the day, the developers are the ones using the technologies and the tools that are purchased, so that's certainly a positive result there. And 60% of respondents endorse technology purchases that build and buy as opposed to purely build or buy. So database administrators, developer advocates, and security professionals less likely to endorse a build and buy approach, possibly due to need to document and safeguard customizations. In other words, it can make their job slightly more difficult, so that kind of makes sense there. So how do people research new technologies? Starting a free trial is the most common way to evaluate new tools. 75% of people are doing that. Almost the same amount are asking developers I know or work with, which is certainly a route I would take. If you have a community and a network of peers, there's nothing like finding out from them, finding out from the source what it's like. So I talked earlier about Svelte, Vue.js, and some other frameworks, and I know people that are using them, and it's really great to hear kind of their experience and some of the pros and cons of those different tools in real world environments. You never know when you're downloading a free trial or trying a new programming language for the first time. Sometimes getting your Hello World application up is great and it's a smooth experience, and then as soon as it scales it becomes very difficult. So I think that's a really valuable way of finding out a bit more about new tools and technologies. So apparently here 75% of developers are more likely to endorse your technology if you provide access to APIs. Hopefully it doesn't come as a surprise to anyone. Make sure to let back-end developers and engineering managers know about the API integrations you offer. They're even more likely to endorse your tech than the average coder. So everyone in the kind of digital space will understand what an API is. So it's certainly good to give other organizations, other developers ways to access your product. And as stated here, that's probably one of the easiest ways to do that. Coding outside of work. Okay, most developers code outside of work as a hobby. 68% of them do so, and almost 40% code outside of work for professional development or self-paced learning from online courses. Now, this is something that's become quite divisional in professional software developers that I know. So I do know professional software developers that do very well and do not code outside of work at all. So they kind of, have the 9-to-5 structure, and they just stick to their role, and they don't spend much time coding outside of work. Some of them maybe have a couple of hours a week given to them by their organization as R&D time, and they'll use that to kind of poke at new technologies. But as you can see here, the majority of professional developers do it because they enjoy it, and you kind of have to enjoy it, I think, to get to a really high level in it. And so if you have a hobby project and you're using other technologies, you've never used Svelte before, so you're going to use that to build your personal website or some hobby project website, it will really help you in your career. So if you do have the time, it's definitely worth doing this, but it's not an absolute necessity. The community section here is mostly kind of promotional content for Stack Overflow, so I won't go into too much detail around that there. So moving on to the professional developers section. We can see, again, some kind of promotional stuff around the professional developer series there. But interestingly, coders are coding more than managing. So 87% of professional developers indicate they're in individual contributor roles, with 13.1% people like myself that are in people manager roles, so people that actually kind of lead technical teams as well as write code. And as expected, the individual contributors have less experience because there's more sort of junior and intermediate kind of mid-level roles there, and the people managers generally have more experience because until you've got your 5 to 9 years of experience, it's unlikely you're going to take on a management role, and that's kind of a minimum there. And apparently 70% of respondents agree or strongly agree that they know where to go to find answers to their questions, and 56% agree they can do so quickly. How quick is quickly? 53% agree or strongly agree that waiting on answers disrupts their workflow, even if they know where to go to find those answers. I definitely encourage people to always try and seek answers out themselves before they kind of go looking for them. That's not to say that you should be worried about asking your peers for answers, but if it's a blocker, as some people have responded here, it kind of disrupts their workflow. Sometimes that extra bit of time spent looking for the answer means you might find it yourself anyway and not need to ask someone. 30% of developers say knowledge silos impact their productivity 10 or more times per week. Knowledge silos aren't a problem for everyone. 45% agree or strongly agree that they're a nuisance, but if you have them, they're a frequent problem. This is something that I've seen everywhere that I've worked personally. Knowledge silos are really difficult to kind of cure, but the number one way for doing it is documentation. So if you can get down onto not paper, but some kind of system like Confluence, or your internal wiki system, and you can actually document the things that are in other people's heads, and that can certainly alleviate a lot of the issues you get with knowledge silos. And we can see here that 61% of respondents, and most people, are spending more than 30 minutes a day searching for answers or solutions to problems, which if you are a developer, you'll know that that's a big part of the role. In fact, I would say that's fairly low, but I guess it depends what kind of project you're working on. But certainly in the initial phases of a project, or if you're working with a new technology, it could be significantly higher than that. It's a big part of the role of being a developer. And we can see here that people managers spend a lot of time answering questions. I can definitely attest to that. 61% spend more than 30 minutes a day answering questions. Again, I would say that would be an absolute bare minimum there. So earlier on, I talked about CI/CD, which is continuous integration and continuous deployment, or continuous delivery, some people call it. But essentially it means can you build and deploy your project quickly. So can you merge code changes and get them deployed to your environment, your test environment, your live environment, whatever it is, with kind of minimal friction there. And we can see that almost 70% of people have a work environment that enables them to do that. So that really is the way that you should be working in today's day and age. And if you're not, it's certainly something you should aim to be getting towards. And we can see here there's kind of a split between hybrid and cloud-only environments, with the on-premise kind of solution being very, very low now. So those are the kind of people that would have a server in their office somewhere. So cloud platforms really have taken over, although you can see there's still at least almost 50% of people using a hybrid solution. And we can see here that search engines are still the most popular type of search tool, but AI has crept up there, but thankfully to nowhere near the levels of a search engine or asking a coworker. And then in terms of common frustrations, so technical debt is a massive frustration. Almost 63% of respondents are frustrated by technical debt. However, they don't agree on how frustrating unreliable tools and services at work can be. So people managers agree it's a second to technical debt, but individual contributors find complex tech tasks or tech stacks, for building or deployment to be slightly more frustrating. So what that means is people that have a variety of tools that they need to learn to actually build their solutions, it can get very complicated very quickly. So if you're using Docker and you have a bunch of packages that you need to, npm packages, for example, that you need to install to get your project working, and then you have some other deployment tools, it can often be quite convoluted just to get your project built and then running locally or deploying. So going back to the CI/CD point earlier, that's kind of one of the reasons you want to get to that point, so that you can streamline some of this. And technical debt, again, I've seen it everywhere that I've been, and everyone I know who's a developer has this frustration as well. And one of the ways to tackle it is to simply spend more time addressing it, and that's kind of one of the issues. You typically on a project, certainly a continuous improvement project, so something that you're working on over a period of months or years, as it becomes a fully developed product, you want to spend around 20% of your time addressing technical debt. So that can be things like refactoring complex parts of the code base and that kind of thing. But most people spend significantly less than that, and so it builds up, and then it becomes quite a pain point for developers. And ultimately, it affects the business by slowing down the development cycle. So software development remains a top industry for developers. 41% of respondents who participated are working in the software development industry. Well, that's not surprising at all. And then fintech, internet, telecoms, banking, financial, healthcare. So these are all in the same ballpark. Only around 20% of people, respondents, said they were happy at work. 32% said they weren't happy, and around 50% of them said they were complacent. If we go down to some of the factors that affect this, we can see here that there are some strategies that might help improve that. So improving the quality of the code and the developer environments. Learning using new tech. I know that's a big one for anyone in the industry, as it should be. You should have a role where you're learning and you're able to use new technology. If you're not, you can become stale very quickly. So I know people do get frustrated if they don't have an opportunity to do that. If you really can't do that in your day-to-day role, kind of going back to our earlier point, it would be really good if you have a hobby project or side project that allow you to experiment with some new tech. And some of the other points here relating to kind of contributions, so contributing to open source, driving strategy for the team, etc. So that's it. Hopefully you found that useful. Definitely recommend coming onto the survey Stack Overflow site and reading through this yourself in more detail, and hopefully use it as kind of a roadmap or something to contribute to your roadmap over the next year. Just be careful with some of the tech stacks and some of the listings around which languages are popular and how much they're paying, because the way that that information is being displayed can be a bit misleading, as we talked about earlier. So certainly don't decide a career direction or what language you want to invest in or become a specialist in next, just based on this survey alone. But it's certainly a good starting point. It's really well put together, and the way they present the data is really useful. I've been reading this every year, so I always find it really useful to look at, and I'll certainly be doing the same next year. Thanks a lot.